Hello and welcome. I'm Raghav and today we will learn about operators in Groovy. This will be easy and interesting, and I will also show you some very basic examples so that you can easily understand operators in Groovy. So in very simple word, operators in Groovy or in any language are symbols that tell the compiler to perform some specific operation. And these specific operation can be an arithmetic operation like addition, multiplication, division, subtraction, can be some logical operation like greater than, equal to, and so on. And we will discuss about this and learn all of these. And to make this easy, I will go to Google and search for Groovy operators. And here you can see we have this official documentation for operators in Groovy. I will go here, and here I will also take this link and make it available in the notes so that you can refer this, and all these notes will be available to you. And here you can see this is the official documentation about operators. We have arithmetic operators, and then we have relational operators and logical operators. So let us start with arithmetic operators, and to do practicals I will go to my Eclipse, and this is the project that we created earlier. I will open this, and inside this package I will do a right click, new, go to others, and I will search for Groovy, and I want to create a Groovy class, so I will go to Groovy type, next, say class, and I will give a class name operators and finish. I do not need a class here, I can directly write the Groovy script here. So we will start with arithmetic operators, and you can see we have addition and the operator is plus, we have subtraction, the operator is minus, we have multiplication which is star, division we have forward slash, and we also use int div for integer division. I will show you this. And then the percentage symbol is for getting the remainder out of a division, and then star star is raised to the power. So we also have these examples. Let me just copy it from here and I will paste it in my Eclipse. Now assert is a statement to just check the statement, that is the right hand side and the left hand side of this equals to. So if the left hand side equals to the right hand side, then it will be true and there will be nothing printed. In case there is any error, then we will have the failure printed on the console. So here you can see 1 plus 2 is 3, equals to 3 should be pass, 4 minus 3 which is subtraction is 1, 3 multiplied by 5 should be 15, which is this. 3 divided by 2, the quotient is 1.5, and then if we use this operator which is for getting the remainder, when we divide 10 with 3 we get the remainder 1, and then this is raised to the power, so this is 2 raised to power 3, which should be 8. Now if I run this, I will do a right click, run as Groovy script, and you can see we are not getting anything on the console. That means everything is fine. Just in case there is any problem or a failure, for example I change this to 7, and now if I run this, you can see we will get a failure here. So you can see a session failed, 2 raised to the power 3, we have 7, however this computes to 8 and therefore there is a failure. So I will just change it back, and also you can see we have int division for integer division. So for example I can say 9 dot int division, and I say 5 here, and this is for integers, and here the quotient should be 1. So I'm just saying assert 9 dot int div with 5 should be 1, and if I run this, and you can see there is no failure, so that means this is working fine. So you can use like this. We also have some operations like I can say 2.2 dot plus, and I can say 1.1, and if I say, if I want to check, I will say assert 2.2 plus 1.1 should be equal to 3.3, and I will run this, and you can see there is no failure, so that means this is working fine. So for these kind of decimal digits, you can also use plus, minus, and so on, which is available in Groovy. And this is about the basic normal arithmetic operators. I will also put this here. And at the end of all of this sessions and this course, I'm going to put this entire project on GitHub, and I will provide you a link so that you can get this entire project from there. So that's why I'm writing these comments as well, so that it is easy to understand. Now let us move to unary operators. This is also a part of arithmetic operators. So here you can see we have plus and minus. These operators are available as unary operators as well. So if we see here, you can see this is also used as arithmetic operators, but we can use it as unary operators like this. Here is an example. So here, if I say plus 3, that means 3. We do not need any sign in case it is a positive number. But if we say minus 4, which this should be equals to minus 4. And then minus minus 1 will make it as positive 1. So this is basic maths, and we can do this with unary operators. If I run this, you can see there is no failure. Also here in the example, it was 0 minus 4, which is again equals to minus 4. So this should also work fine, and this is working fine. So this was very quickly about unary operators, and then we have this increment and decrement operators as well. So here let me show you this increment, which is plus plus, and decrement, which is minus minus. These are the operators. So for example, if I say int I equals 10, and then I say print ln I plus plus, so what should be the output here? So here this is a post increment, so that means the value gets incremented after it is assigned. So if I just run this, you can see we are still getting 10. However, after printing, it has been incremented. So if I try to run this, if I try to print it again, this time they should give me 11. And you can see now it is second time it is giving me 11. So this was, here it was 10 and here it became 11. And if I say pre-increment, which will be plus plus 1, so here itself it will become 11. So let me put this in a bracket. Now if I run this, you can see we are getting 11. So here you can see there are some examples, and here we have some documentation. The postfix increment will increment A after the expression has been evaluated and assigned into B. So here we have these examples. Then we have postfix decrement, prefix increment, and prefix decrement, and these are some examples that you can see. If I just copy this and paste it in my code, you can see here the first example is a equals 2, and then in B we say a plus plus multiplied by 3. Now here, because this is post increment, a still has the value 2. So when we say a plus plus multiplied by 3, the answer should be 6, and therefore here we have this assert a equals 3 and b equals 6. So b should have 6 here, because a, sorry, there was a mistake here. When we say a plus plus into 3, a is still 2. It was not 3, it was 2. So that was my mistake. A is still 2. So this is 2 multiplied by 3, which is 6. And here after increment, after this statement, a has got the value 3. So here we are saying a equals 3 and b equals 6 should be pass. Similarly, there are some other examples for decrement, and here you can see these examples. So this is all about increment and decrement. And then let us look at assignment operators. So here I will say these are assignment arithmetic operators, and these are the operators: plus equals, minus equals, star equals, and so on. And if I give you an example, I'll paste it here. So when we say a plus equals 3, this is equivalent to a equals a plus 3, and we are getting an error because we have already defined a earlier above. So I'm just going to comment everything. I will select everything and press Ctrl and / on my keyboard. If you are on Mac, you can press Command and / to increment to comment all this. And here let us see again. So this statement means a equals a plus 3, so the output should be a plus 3, which is 4 plus 3, that is 7. So here if I say assert a equals 7 should be true or should be pass. Similarly, we have this when we say b minus equals 3, this is equivalent to b equals b minus 3 and the answer should be 2. So we can say assert 2 here, and this should again be pass, and everything is working fine. And similarly, you can see all this. The same thing we can use with other operators like multiplication. When we say c multiplication equals 3, that means c equals to c into 3, which should be 15. Similarly for division and modulus or remainder and raised to the power. So you can see this. Let us come to relational operators. So we will quickly look at relational operators. So here you can see we have these different operators. We have equals to that checks the equalness. So relational operators allow comparison between objects. So to check both objects or both the sides of this operator are equal, we use equals. To check not equals, we use not equal, this symbol. Then this is for less than, greater than, less than equals to, greater than equals to. And here we have these examples. I will copy this here, and here you can see assert 1 plus 2 equals 3. So this operator checks the equalness at both sides of this operator. Not equals to checks that this should not be equal to. This is less than, so minus 2 less than 3 should be pass. This is less than equals to 2 less than equals to 2 should be pass. 3 less than equal to 4 should be pass, and similarly this is greater than and greater than equal to. If I run this, everything is pass. So this was relational, and then we have some logical operators, and here I will put this here, logical operators. Now here you can see we have these three logical. This is logical and, logical or, and logical not. Now here when we use and, both sides should be true. So this is and is true and true is true. If there will be any one false, it will be false. Or has, in case anyone is true, it will be true. So if we have true or false or true or true and true, it will be true. Logical not will be just the opposite. If we are saying not false, it will be true. Not true will be false. So if I take these examples and put them here, so assert not false will be true, so this statement will pass. Assert true and true will be again be true because both the sides are true. Even if one side is false, it will give out false as the output. And then assert true or false, they here any one should be true and it will compute to true. So this should pass again. I will run this and everything is okay. So we also have this concept of precedence. So the logical not has higher priority over the logical and. So if I take this example, so the not operator has higher precedence. So in this statement, this will be computed first. So this will turn into true, and then true and false will be false, and this entire statement will become true or will become pass. And then here the logical and has a higher priority than logical or. So here this is another concept of logical operators. The and operator has a higher priority. So if we have and or both in the single statement like this, first it will compute and, so true and false will become false, and then true or false will finally give true. So this is the concepts of logical operators, and everything is fine. And then we also have a concept of short circuiting. So the logical OR operator supports short circuiting. If the left operand is true, it knows that the result will be true, and in any case it won't evaluate the right operand. So if you see this OR, so for example, it will start computing from left, and if it finds true here, it will ignore everything else because it knows even if one is true, the answer is going to be true, so it will just output true. Similarly for AND as well, if it finds it will start computing from the left. If it finds false at the very first instance, it will not compute anything else, it will just return false. So this is called short circuiting. It is applicable to OR as well as AND operator, and you can see this example as well. And then we have bitwise operators. Let me just show you very quickly what do we mean by bitwise operators. Now here we have these four bitwise operators: bitwise AND, bitwise OR, bitwise XOR or exclusive OR, and bitwise negation. So here the concept is same like we had the logical operators. The difference is it applies to the byte or the binary of the particular element. So AND will be true if both is like we have 1 and 1. Otherwise if we have 1 and 0, it will be 0. 1 and 1 will be 1. Or is like 1 or 0 will be 1. If we have either 1 1, it will compute to 1. This is the opposite of OR. So here it is something like this. If I show you, if we have 1 or 0, it will be true. If we have 0 or 1, it will again be true. If we have same at both the sides, it will be false. So this is exclusive OR, and then this is not. Now to show you an example and to understand this, let me just show you here. Suppose I have an integer a which is equals to 20, and I have an integer b which is equals to 25. Now if I say println and I say a and bitwise and b, and what will it this print? So if I run this, you can see it is printing 16. However, how is this 16 coming? So let me just explain this to you. So I have to convert 20 and 25 to their binary form first. So for that, what I can do is I can say integer dot, we have a function to binary string int, and here I will say 20, and again I will say println integer dot to binary string and 25. And if I run this, you can see this is the binary representation for 20, and this is the binary representation for 25. Now when we apply the bitwise AND operator here, so what does that mean? Let me just show you here separately. So here you can see 1 and 1. So 1 and 1, or you can take it as true and true, it will be 1. It will be 1. Then 0 and 1, it will be 0. So this will be 0. 1 and 0 will be again 0. Then 0 0 should be 0 again, and 0 1 0 again. So this is the output, and then we have to convert it to integer format. So again I can convert it into an integer. So I will say println integer dot parseInt, and I want to convert this value which is 10,000 to integer, and this should give me the result of a and b, which is 16. So if I run this, let me just see, this is integer dot parseInt, and here okay, we are getting this. let me say to the base 2 or decimal base, and yes, I am getting 16 here. So do not worry if you are not getting this. This is bitwise operators, and this applies on the binary form of your numbers. And here you can see it can be applied to byte or int and returns an integer. So when I say 20, 25 and say A and use bitwise and say B, so this will compute the bitwise and for 20 and 25, the binary formats, and whatever comes out it will change into an integer and then give us the output here. You can also see some examples here. So this was bitwise, and if we look at conditional operators now, so I will comment all of this and we will see some conditional operators. So here we have all these operators. Let me just show you. So the not operator is represented with an exclamation mark, not operator. So here if I give you this example, so not true will be false, not foo, so this is actually, this is not null, so not null will be again false. If I say not of this, this can be true, but again this will be false. And yeah, they have given the example here as well, so not of null will again be true. So this is what is not operator. And then we have ternary operator. So ternary operator is a short expression for if else. So suppose you see this example, if string is not equals to null and string dot length is greater than equals to 0, then output result equals found, otherwise put results equals to not found. Now you can write this in a single statement using a ternary operator like this. Result, if we have something in the string, then we have to put found in the variable result, otherwise we will put not found in the variable result. So if I just show you in a simple way, so this is ternary operator. So let me just show you. I say I take a variable output 1 and I say this is equals to I give some condition 1 is greater than 0. If this is true, then in the output 1 I want to put 1 is greater than 0, and else, which is represented by this semicolon, I want to put in output 1 variable 1 is not greater, or let me keep it simple, 1 is greater and 1 is not greater, and then I will just print output 1. I can also put it as a string or def. So now if I run this, you can see it is saying 1 is greater. So output 1 got the value 1 is greater because this statement was true. Now if I change this, now this is false, so it will not take this, it will take this particular value. So if I run this now, it is saying 1 is not greater. So this is about ternary. We also have Elvis operator, which is even further shortening of the ternary operator. So something like this, user dot name, then we put the question mark as well as the semicolon here, and then we put these values. So you can look at it, Elvis operator. Then these are all the basic operators. We have many more operators like object operators, and then we have these regular expression operators and so on, which comes into advanced programming. So we may discuss it later on, but these are all about the basic operators in Groovy. So I hope this session was very useful for you and you have properly understood about operators in Groovy. I will meet you in the next session of Groovy. Thank you for watching.